Hello students, Sacred Heart High School welcomes you. Today we are going to study in Science-1, Chapter 1, Gravitation, Part 2. Today we are going to study about Earth's gravitational acceleration. Now you can see the picture of a girl standing on the road, a car on the road, and a dog jumping. It shows that the Earth exerts gravitational force on objects near it. Now see this picture. What do you see? The boy is exerting a force to pull the box. In the second case, you can see that a man exerts force to kick the ball. This explains that according to Newton's second law of motion, a force acting on a body results in its acceleration. Thus, the gravitational force due to the Earth on a body results in its acceleration. Now, in the third picture, you can see a man throwing an object from a great height. What you see in the beginning, the speed of the object will be less, and as it falls downward, the speed increases because of the gravitational force due to the Earth. Acceleration due to gravity is denoted by the letters G. Acceleration is a vector. As the gravitational force on any object due to the Earth is directed towards the center of the Earth, as we had seen, the direction of the acceleration due to gravity is also directed towards the center of the Earth, that is vertically downward. Now we shall derive value of G on the surface of the Earth. We can calculate the value of G by using Newton's universal law of gravitation for an object of mass m situated at a distance r, that is, it is denoted by small letter r, from the center of the Earth. The law of gravitation gives as F is equal to G mm upon r square, where the capital M denotes the mass of the Earth. Now, as we know, force is equal to a mass into acceleration. Here, acceleration is denoted by G because it is acceleration due to gravity. Now, from this, as we know, if we substitute in place of F by mg, so the equation becomes mg is equal to gmm upon r square. Now, both the side m gets cancelled. So, what do we get? G equal to gm upon r square. So, we substitute over here G equal to gm upon r square. Now, this r, small letter r, we know that it is the radius of the Earth, so it can be, both are equal, so it can be replaced by G equal to gm upon capital R square. Now, we know that the unit of G in SI unit is meter per second square. The mass and the radius of the Earth are 6.6 multiplied by 10 raised to 24 kg, and radius of the Earth is 6.4 multiplied by 10 raised to 6 meter. So, we'll substitute the value in the equation. And the value that we get for G is 9.77 meter per second square. So, this acceleration depends only on the mass and radius of the Earth. So, the acceleration due to gravity at a point on the Earth is the same for all objects it does not depend on the properties of the object. Now we shall see the variations in value of G. Will the value of G be same everywhere on the surface of the earth? The answer is no. Now as you can see picture, the reason is that the shape of the earth is not exactly spherical, and so the distance of a point on the surface of the earth from its center differs somewhat from place to place. So we know that it's ellipse. So you see that it bulges at the equator and flattens at the pole. Henceforth, it is not round in shape. So it is somewhat this, the shape is this, how you can see in the picture. So you can see that as we have said that it is not exactly spherical. So the distance of a point on the surface of the earth from its center differs somewhat from place to place, and due to its rotation, as we have seen that earth bulges at the equator and it's flatter at the poles. So you can see its radius is largest at the equator and smallest at the poles. Hence, the value of G is thus highest at the poles, that is 9.832 meter per second square, and it decreases slowly with decreasing latitude, that it is lowest at the equator, and the value of G is 9.78 meter per second square. So the value of G differs or changes along the surface of the earth because of its shape. Now as we go above the earth's surface, the value of R, as we have seen that G equal to Gm upon R square, increases and the value of G decreases. However, the decrease is rather small for heights which are small in comparison to the earth's radius. For example, suppose the radius of the earth is 6,400 km, and if an aeroplane is flying at a height 10 km above the surface of the earth, its distance from the earth's surface changes from 6,400 km to 6,410, and the change in the value of G due to is negligible. Now as you can see in the picture, just will explain. Now we know that the value of G on the surface of the earth is 9.83 meter per second square. Now suppose there is a Mount Everest which is at a height of 8.8 kilometer. The value of G is 9.8 meter per second square, so it is negligible. Now suppose a man-made balloon reaches at a height of 36.6 kilometer. The value of G is 9.7, that it decreases. It's very small and decrease. You can see the value of G. Now as suppose a typical weather satellite which is launched at a height of 400 kilometer, you can see the value of G decreases to 8.7 meter per second square. So the value of G decreases from 9.83 to 8.7 meter per second square. Now suppose a communication satellite which is launched at a height of 35,700 km, the value of G decreases to 0.225 meter per second square. So we can say that change in the value of G due to the large change in the distance of the satellite from the center of the earth. So this shows that as the height changes, as we go higher and higher, the value of G decreases. Next we shall see the value of change, does it change with the depth? Now we have seen that the value of G decreases as we go above the Earth's surface. Now we shall see what happens when we go inside the Earth. As you can see, there is a girl standing on the surface of the Earth. Okay, now the girl moves, or she moves inside the Earth. As we know, according to the equation, G is equal to Gm upon R square. It decreases, so value of R decreases, and you would think that the value of G should increase because it is inversely proportional. However, the part of the Earth which contributes towards the gravitational force felt by the object decreases. So the mass, that means the value of m to be used, is decreases. That means the value of G is directly proportional to m. Henceforth, if m decreases, mass of the object decreases, obviously the value of G also decreases. So you can see, as a result, when the girl reaches to the center of the Earth, the value of G is equal to 0. That is, we can say that the value of G, with the combined result of changes in R and M, it decreases as we go deep inside the Earth. So you can say that the value of G at the center of the Earth is 0.